Hello, my name's Peter Parsons. I'm a solution architect at Progress Chef, and today it gives me a great pleasure to introduce Rohit and Justin from SAP, who are going to talk about operating at scale in a multi-cloud landscape. Over to you guys.
Awesome. Yeah, thank you so much, Peter. In this session, we will be presenting with an overview of internal CSPM solution that SAP uses to run the compliance scans. We'll be going over how SAP runs compliance scans at scale to cover thousands of cloud accounts, millions of cloud resources across AWS, Azure, GCP, Ali Cloud, and also the AWS China and Azure China regions as well. It's quite clear that running security operations at such a huge or enormous SAP scale, we come across some really complex problems and have to deal with a lot of obstacles. So to give a good walkthrough on, we will also be covering some of the operational complexities we came across while developing this internal CSPM tool. Uh, and also we'll be going through some of the scaling issues we faced and the solutions we typically use to overcome those. So moving forward with the agenda, so we'll be covering how and what the scale of SAP's cloud landscape looks like, the tool architecture that we have developed to run the compliance scans across the 4 cloud providers. So how the architecture for that tool and how we have architectured that, and how it looks like, how we operate, or what are the day-to-day security operations that are required to run the compliance scans, and what it looks like. And finally, some of the operational takeaways into running the compliance scans at this enormous SAP scale. So to move ahead with the introductions, I'm Rohit and I work as multi-cloud DevSecOps engineer. I've been involved in various cloud security projects at SAP, and I've been also actively involved in implementing cloud security and compliance within SAP. So, but it's really great, and I'm really delighted to be speaking here at ChefConf. So I'll hand it over to my colleague Justin from here.
Hi, everyone. My name is Justin Nichols. I'm super excited to be here at ChefConf and just want to thank Chef Progress for having us and allowing us the space to talk about what we do. I've been on the multi-cloud SecDevOps team for a year and a couple of months. I've been at SAP for longer than that. But Rohit and I have been working together along with the rest of our team at building out an internal CSPM solution using Inspec and some other components that we'll touch on a little bit. But really glad to be here, and yeah, we'll just go ahead and get started talking about our cloud landscape. So with SAP's cloud landscape, we are truly multi-cloud. So we've got AWS, GCP, Azure, and Ali Cloud. We're operating on each of these cloud providers. You can see the number of accounts that we scan on each of these providers. We have about 4,500 on AWS, about 3,000 on GCP, almost 5,000 on Azure on multiple tenants, and a little under 200 on Alibaba Cloud. And when it comes to AWS and Azure, we're also operating the China-specific tenants of those cloud providers as well. So we're able to not only operate with the global tenants of those providers, but also combine all of our data from those China-specific tenants into a single place. We've developed quite a few controls across each of these, and these numbers fluctuate all the time, as Rohit will cover in our release workflow section. But right now we have 59 controls on AWS, 31 on GCP, 33 on Azure, and 19 on Ali Cloud. And again, with requirements changing, those numbers change. We break controls apart, combine controls kind of all the time. So again, Rohit will touch on that later. So if we take a look, not at the number of accounts, but the number of resources, you can see this growth has been tremendous at SAP over the last few years, pretty much doubling in number of resources every year. Maybe next year at ChefConf, we'll be able to give you our January 2023 number, and could be double there as well. So we have been operating at this crazy scale that's continuing to grow. But keep this in mind as we talk about how we operate, the issues that we face, especially with these number of resources and the vast configurations that we run into. This is kind of how we get to the ability to stress test our solution, stress test in spec as we operate. It's a really great opportunity to do that. So when it comes to our solution, you may have seen some other talks in previous years about the more technical aspects of what we do. We have containerized in spec. This particular session will remain higher level. I'll talk about the different pieces of our end-to-end infrastructure in a high-level way. I'm not going to specifically mention how those are implemented. And if you're interested in that, maybe we can connect and we can send you links to some other talks that have happened previously. So when it comes to our infrastructure, we have these three high-level areas. We have our preparation, our scanning, and our reporting. So in our first phase, we prepare and gather data on our cloud accounts. So we request all the information about the different accounts, account IDs, sorry, under each organization for each of these cloud providers. We then gather additional metadata. We have an internal database that has information about owners, security responsible individuals that are attached to those specific accounts. All that data is gathered, and we queue that account up for scanning. And at that point, once we're ready to scan a list of accounts, we retrieve a specific account ID that's queued up. We then scan this by executing a workload on our Kubernetes cluster, which that workload is simply just containerized in spec with some additional logic wrapping it. And then once we move on to the reporting section, this is where we aggregate data, send out compliance information to account owners and executives to get a better understanding of where a particular account, where a particular line of business is when it comes to compliance and security. So again, we start by gathering all this metadata. We then scan an account, and then we send out the data on that account to give visibility into the configurations and misconfigurations on those accounts. So just want to reiterate, we are using inspec for these configuration checks, and we have other infrastructure pieces around it and some additional logic, but inspec is kind of at the heart of our scanning. From here, I will hand it over to Rohit to talk about how we operate and he will give us some insights into the process that we follow.
Yeah. Thank you so much, Justin. So in this section, we'll talk about the release process that we have internally designed in order to run these compliance scans and make compliance scans possible at such a SAP scale, and to operationalize the process that Justin has talked about previously. So to start off with the release workflow, so as we all know, we need a certain planning and operationalization to be in place to run the compliance scans at such a huge scale at SAP. So to to get to the point where we want to, we need to have like a really strict process in place, and we have designed our release workflow on how the control updates and all the changes are deployed into production and the compliance scans runs. So SAP's in-house CSPM tool is built based on Chef Inspect, as Justin previously mentioned. Uh, so in our release workflow, we typically follow a ring-based approach where we have three phases to it, namely the requirement gatherings, implementation, and the feedback. So the feedback phase ultimately leads us back into the requirements gathering phase, which we'll see how that happens into the upcoming slides. But each release essentially consists of the various things related to the controls written in Chef Inspect. So that will essentially range from the control updates and the improvements. So what they are, how that exactly is done, we will look into the upcoming slides. But to stress on this part is like we do these control changes very dynamically on a very rapid basis, depending on what the requirements are and what the feedback is, what the industry standard is going on. And we do this release cycle. We follow the release cycle typically of 2 weeks, and we pass on these control updates to production every 2 weeks. So like now that we know how the overview of the release workflow looks like, let's jump into some details of the first phase, which is the requirements gathering phase. So SAP's global security team, which is also known as SGS, so they are the SAP's security policy owners. So we conditionally receive the security policy updates from SGS over the period of time. Like it depends what the time frame is, but we typically receive it like within 2 weeks, within a month's time, and so on. So once we receive those updates, we convert the policy updates into code using Chef Inspect in the form of the Chef Inspect controls. So these requirements can range typically from addition of the new controls, the changing or updating the implementation of already existing controls we have, and finally deactivating the existing controls. So the deactivation of the controls can again depend on the feedback we receive, or if a certain industry standard has changed, or a certain change has been occurred at the cloud provider level. So that warrants, and like we need to make the deactivation of the controls as well. So the feedback from the customers that we receive, essentially that gets converted into a requirement again, and then that ultimately drives us into the requirement gathering phase. Moving on now with the second phase, which is the implementation phase. So in this phase, once we have all the requirements, once we have gathered all the requirements from all the different sources, uh, we convert these requirements into issues, and the actual development over these requirements start into the implementation phase. So there might be a different requirements ranging from the control updates, addition of new controls, deletion of the previous ones as mentioned previously. At some points, or in some cases, we might even need to do the Chef Inspect resource pack edits, which we have been actively contributing to the AWS and Azure resource packs, depending on what the requirements are. So this edits can range from addition of a completely new resource that we require to write the control for, or basically to add a new function or a defined new function in the existing resource and use that function definition in our control to check for compliance. So when a new control development is involved, there are various testing processes we follow till the point we are deploying that change into production. But to start off with the local testing, we have developed our own integration test suite where we deploy the resources using Terraform to the cloud accounts. We write the chef inspect control or as per the policy or the requirement that we have received, and run the control against those resources to see whether the control is working as expected. So the typical test cases that we use are the good and the bad tests, wherein we deploy good resources and the bad resources to the cloud account and run the control against that. So ideally, the control should be passing for against the good resources, and the control should be failing for against the bad resources. So, and we also cover the different edge cases if depending on what the policy is. But this just gives us a confidence of okay, so everything has been tested thoroughly, and the control is working as expected. So once this local development is done, we deploy the entire workload to the development environment on which the scan runs through Kubernetes, as Justin has previously mentioned. So depending on what the results are, we typically check for if there are any obvious bugs or if there are any control source code errors. If there are any, we just make a point to resolve those and then deploy the workload again to develop to make sure everything's working fine. Once we have tested everything and made sure that it works properly into the development environment, we deploy the workloads again to pre-production. So pre-production is the stage where the entire scan runs at scale, and we make sure that all the updates that are included in the release are working as expected to the scale, because we might run into some issues or the scaling issues we will be discussing in the upcoming slides. So we just want to make sure that we are running through the release on the entire SAP scale and run the compliance scans to make sure everything's as expected before moving forward with the production release. So as far as the results analysis takes place for the pre-production, we make sure that the control updates that we have pushed are taken into effect. And if there are any false positives reported by the internal lines of businesses, we make sure that the accounts on which these false positives have been reported on are resolved. And we also take a note of the number of what the numbers looks like with the new control additions, and make sure we have that thing documented to send out and broadcast throughout the organization. So once this pre-production results have been analyzed, we are finally ready for our production release, which happens every 2 weeks. So we deploy the workloads to the production from where the compliance scan triggers, the reports are generated, and the reports are again sent back to the entire and distributed across the entire organization to give them an idea of how the cloud landscape looks like. So moving forward with the last phase of our release workflow, which is the feedback phase. So there are different sources from where we receive the feedback on these controls. So that typically is the SAP's global security team, that is the SGS team that was mentioned in the previous slide. The individual lines of businesses. So these are the business units to which we distribute the scan results. So depending on what the results looks like and what the individual use cases are, we receive feedback from them as well. Uh, like we host security officers every week where the entire SAP community is invited, where we provide updates and we open up the floors for them to ask questions. And many a times it happens that these questions ultimately lead back into the requirements. So as you can see how a circle completes, where like we receive updates, the implementation phase goes on, and then the feedback phase ultimately drags us back into the requirements gathering phase, and the release cycle completes. So now that we have understood how the release workflow looks like and how we do compliance scans at scale, let's move on to a very interesting topic of operational takeaways, where we will go over some of the operational complexities and the scaling issues we face. We'll discuss a typical use case of how the release workflow looks like whenever we receive a certain requirements, how it flows through the entire release workflow, be it like reporting of the false positives by the internal lines of businesses, or the feedback and the requirements that we have from SGS. So uh, let's get into the first one, which is related to the AWS S3 bucket, where we receive feedback from one of our lines of businesses where they were reporting for a possible false positives. So this was related to one of the AWS S3 bucket control that we had, that was enforcing for a S3 bucket to have TLS encryption enabled. So in the control, we were having has secure transport enabled function. So that function is already defined in the resource pack, and we were using that control in our we are using that function in our control to check for compliance. So what this function does is it ensures that a specific statement is defined in a bucket policy for that AWS S3 bucket. So what we had claimed received from LOB was they had the right bucket policy configured with the right component defined in the bucket policy, but still they were receiving some kind of false positives related to the S3 buckets in those accounts. So this is a requirement that we received that ultimately transferred, and we went into the implementation phase where we took some steps for troubleshooting. Uh, so the first step that we took was we ran the scan, we ran the control locally. We deployed a bunch of resources on our test account, ran the control against it, just to make sure and find out whether the issue lies at the infrastructure level, whether it's at the control level, or whether that's something at the resource pack level. The second, what we did was, after making sure that the control was working fine locally, we logged into that account on which the issue was reported. So we typically use org level read-only creds and the assume role function to log into each of the account in an organization and run the scan. And we ran the control, tried to reproduce the issue there. And yes, the control was failing. The next step was to make sure that the bucket policy was rightly configured for the AWS S3 buckets from the console. And yes, over there as well, we could see that the bucket policy had all the right components that were necessary for the TLS encryption to be enabled. So ideally, the control should have been passing, but still the control was failing. So that made us think that everything's working fine at the infrastructure level. The control is written fine. The control testing is working fine locally. The bucket policy is rightly configured. So that made us think and concluded that there is definitely some kind of a issue with the function definition that is defined in the resource pack. So moving forward with the solution, what exactly was there? Something really interesting. So the function that was defined in the resource pack was detecting only a single level of hierarchy inside the condition block of the bucket policy, as we can see in figure 1. So the bool and AWS colon secure transport colon false. So that essentially gives us that the TLS encryption is enabled, but the function definition was just detecting this single level of code block inside the condition block. So what was happening was there were a bunch of AWS S3 buckets in the account that had a multi-level of hierarchy or a code blocks defined inside the condition block. So the function definition was not able to catch that, and even when the TLS encryption was enabled through the bucket policy, and the bucket policy had all the right configurations, the function definition was not able to catch it, and hence the control was failing. So we took all the necessary steps. We modified the control, the function definition. We made the contribution to the AWS resource pack with this fix. Once the PR was merged into the AWS resource pack, we were then able to push this fix as a hot fix into the production. And eventually, with the next scan, all the false positives related to this issue was fixed. So that's typically how the entire release cycle works. And uh, moving forward, like again, justifying the SAP scale, there's another one interesting issue we faced with scaling, and that's typically with HTTP 429. Uh, so this is something issue that we face on a huge scale that SAP operates at. So HTTP 429 errors are nothing but the API throttling issues. That is the API rate limits getting exceeded. So in the cloud provider or in the cloud world, what typically happens is there's a API quota that's associated with the subscription and the tenant and the resource level for Azure at the project level for GCP. So whenever that API quota gets used up, whatever that is, it depends from cloud provider to cloud provider. But whenever that API quota gets used up, the API rate limits exceed, there's timeout, and then we get HTTP 429 errors. So this typically happens when there are enormous amounts of resources in a certain account or a certain subscription or a project. So during the initial phase of our internal tool, CSPM tool go live, we hit into a large amount of almost around 11,000 erroneous HTTP 429 results per scan. And this was typically with Azure and GCP. So as we can see in the screenshot, we have put in under the inspect control example on how the initial control implementation looked like and how that caused issues and resulted into the API throttling. So we were looping through the resource groups individually and then getting the list of all the storage accounts attached to the resource group, and then checking for each storage account individually for compliance. So what this resulted into was the number of API calls, which was equal to the number of resources. So say, for example, if a certain subscription or an account had 1,000 storage accounts, this led to 1,000 API calls, resulting into API throttling. So what this means is if a number of storage accounts attached to a certain resource group increases, the number of API calls increases, and the possibility of us running into the API throttling also increased. And like the problem got even worse because we even did not had any insight or any analytical insight into by how much amount was the API rate limits getting exceeded. So that even made our troubleshooting process much difficult because we were not able to go to the cloud providers and ask them for increase in the API quotas because we did not had the exact number on what the API rate limit exceeding was. Uh, ultimately, even because we did not had that analytical insight into how much API quotas are being used by our compliance scans, and on the other side, also with the automation activities that, or the day-to-day activities that are done by the relevant account owners as well. So the only solution that we could think of is optimizing our control code. So as you can see in the screenshot mentioned under the solution component there, we changed the control implementation, wherein we were just getting all the attributes related to all the storage accounts under a particular resource group through a single plural API call. So what this means is we were able to significantly reduce the number of API calls from like one per storage account to one per resource group. So irrespective of what the number of storage accounts are attached to a resource group, and if the storage accounts, even the storage accounts increase attached to a particular resource group, we'll still have just one API call checking for compliance, because we'll just be using one plural API call to get list of all the storage accounts and the attributes, and then parse through that output to get the attribute that we need to be used in the control to check for compliance. So once we optimize this control code for like a bunch of controls, we could see literally a significant improvement in the results, wherein initially we had like around 11,000 erroneous 429 errors, which was then reduced down to just 20 per scan. So that was really a big and a significant improvement. And that shows the level of the design complexity involved into designing such an infrastructure and running compliance scans at scale. So from here, I will hand it over back to Justin, where he will walk us through some additional important operational complexities we faced. Over to you, Justin.
Thanks, Rohit. So we've seen a couple examples so far of some operational complexities that we've run into. One had to do with function definition in the resource pack. Another had to do with the way that we write our controls. Here's one that's a little different. It took us some time to figure out as well, because it's not the issue occurred in an area that's not typically a problem for us. So we'll go into this. So we had received some feedback that there were false positives on a handful of S3 buckets throughout our entire landscape. So it was not many. It was just a handful, and we had noticed that all of these instances of false positives were occurring in regions that require to be opted into for AWS. So our typical first steps in troubleshooting, Rohit mentioned, where we're running the scan locally, and in this case, we ran the scan locally, and we weren't able to reproduce the issue. The S3 bucket was scanned, it was reported correctly. So Rohit and I were working on this together. I was unable to reproduce it locally. And then he had informed me that he was able to reproduce it locally. So we went through this whole long process of trying to understand what's different about our environments. How do we have two different results running the same exact control, same exact version of everything that we were running? The difference that we ended up finding is that Rohit was generating his access token to this account using the Bodo 3 client in Python for STS, and I was using the AWS CLI. So that's the only thing that we could end up coming to decide was different between what we were doing. And so moving on to the solution, we dug through a bunch of documentation, and we found this particular documentation that we have linked that talks about regionalized endpoints for STS. And if you notice here in this table, which is from the linked documentation, the AWS CLI defaults to using regional endpoints for STS, which AWS recommends using these regionalized endpoints as opposed to the global endpoint. So the token is generated using regionalized endpoints, but with the Bodo 3 client, it does not default to use regional. It defaults to using global. We're able to update this or change this environment variable here to use regional endpoints for the Bodo 3 client. Once that was done, we didn't experience the issue anymore. We were able to fix that. So here's just kind of an example of the various areas that that things can go wrong, and the initial problem may really have no indication of what that solution is, as is here. The token was the access token was causing the issue, and not the control itself or the resource pack. So that this was an interesting one for us to get to the bottom of just a couple weeks ago, actually. So this last issue here indicates the scale that we're running at, and some of these odd complexities that we run into due to that scale. So this is actually from last year at this point. We had noticed that a handful of our accounts were not being fully scanned. So we have this queue of we have this queue of accounts for which they're waiting to be scanned, and these about 10 accounts or so were just sitting in that queue, not getting picked up, or they were getting picked up, but they were just never completing. And we also observed that there was consistent growth in memory allocation over time. So we would have this memory allocation build up and build up and build up and continue building up until it really led to some issues in performance. So when it comes to troubleshooting, we started by just running one of a scan against one of these accounts that we were aware it was not completing. When we ran that locally, it did not complete. It just kept running and running and running until the token ended up expiring. So we have our controls broken up into multiple profiles. So we then started to target specific profiles to understand which profile is taking a while. And then we ended up narrowing that down, and then narrowing it down to a control that's using the AWS ECR repositories resource. So this one particular control was not completing, which was causing the entire scan to fail to complete. So I will move on now to the solution. I'll give everyone a couple seconds to look over this code. Maybe we can get some people in the chat to guess what they think might be wrong. The issue is in this block here, and I've referenced the PR in this slide as well. So if you want to take a look at it, you can do that. But I'll just wait a few seconds, see if anyone spots it. So highlighting here, the query params. This is where the issue lies. And if you notice at the top, the query params with the max number of results is referenced as an instance variable. And this highlighted line, it is not referenced as an instance variable. So what's happening here is we're setting the max number of results for the request to receive up at the top with an instance variable. We're passing that instance variable into the API call. And then we're getting the first 1,000 results. And for most of our cloud accounts, there's less than 1,000 ECR repositories that exist. So we would never reach a scenario where there's more than 1,000 ECR repositories, except for a handful of accounts. And those are the handful of accounts that we're failing to complete. So you'll notice here that at the bottom, the query parameters then sets, or we then set the next token, which then would get the next 1,000 results after the first 1,000 results. But the variable that's being updated is not an instance variable. This is not referencing the same variable. So it would go back in the loop, then again, send this query params, but that query params was never updated. It just gets the original 1,000 results rather than getting the next 1,000 results. So what was happening with this handful of accounts with over 1,000 ECR repositories was it kept just querying the same 1,000 repositories over and over again, leading to that increase in memory usage and also preventing the scan from finishing. So this was a small PR. We just had to add that little @ symbol to make that reference the same instance variable. And once that was done, things were working just fine. We were able to then page the results as it should, and those accounts were able to be completed. So the issues that we ended up covering today, we only covered 4, obviously, with some time constraints, but we run into different operational complexities all the time, every day, every week, interesting things that come up with the scale that we're running at. So we just wanted to put it out there, like, feel free to reach out to us with questions, and we're happy to talk about our experience with resolving some of these complexities. And we're happy to continue to build out the community around Inspec and work with Chef Progress. So thank you all for attending our talk, and I will pass it over to Peter.
Thanks, Justin. Thanks, Rohit, as well, for a really fascinating insight into how SAP is using Inspec and doing so at such massive scale. And I'm certainly interested to see what the coming year will have as well. So thank you very much.